Hello, this is question 8 in your June 2022 Pure 1 paper from edexcel. You have a car stops at two sets of traffic lights. The figure 2 shows a graph of the speed of the car. So this is a velocity time graph and it's doing this. The car takes t seconds to travel between the two sets of traffic lights. So here velocity is 0 and here velocity is 0. Also the car increases the velocity and then decreases and stops again. The speed of the car is modeled by this equation. So this equation is represented by this graph. Where t seconds is the time after the car leaves the first set of traffic lights. According to the model, find the value of t. So t is one of the roots of this equation. So it's going to make v 0. So let's going to find that. I'm going to make that equation equal to 0. I think I'm going to do it in the next page. So for a, velocity is going to be 0, which means that 10 minus 0.4 t ln t plus 1 is going to be 0. I have two factors. The first one, t minus 0.4 t, 10 minus 0.4 t is 0 when t is 10 divided by 0.4 or 25 seconds, and the second one is going to give me the other value, this one. So it's going to give me t is 0. So when I do that, I have that t plus 1 is e to the power of 0, which is 1. Therefore, t is 1 minus 1, 0. So these are the two values, but they are asking me in particular by this one. This one is t, capital letter T, yeah, 25 seconds. B, they say, show that the maximum speed of the car occurs when t is this value, and you see that the t is not the subject because you have here a t inside the ln. So we have to try to find this expression somehow. Maximum speed is going to happen when the derivative of the velocity is 0. So what we're going to do is to derivate this function, make it equal to 0, and try somehow to find this expression. So I'm going to make dv over, so for b, I'm going to do dv by dt. The expression is here. Yeah, I have two functions, so I can use the product rule. So I'm going to multiply the derivative of the first one, which is minus 0.4, by the second one, plus derivative of the second one by the whole first expression. And derivative of ln t plus 1 is 1 over t plus 1. And this must be 0, which means that 0.4 ln t plus 1 is going to be 10 minus 0.4 t divided by t plus 1. We need to make this t the subject, but we can leave this as it is. So I'm going to multiply by t plus 1 both sides, and I expand the bracket. So I'm going to multiply this thing here by t plus 1 and expand the bracket altogether. So I have 0.4 t ln t plus 1 and 0.4 ln t plus 1 is going to be 10 minus 0.4 t. And I'm going to put the t's together, but not the ones that are in the log, but this one together with this one. So I have 0.4 t ln t plus 1 plus 1 that comes from this one here, and this is equal to 10 minus 0.4 ln t plus 1. So this one here goes minus, which means that I can make t the subject on my left hand side, and I have 10 minus 0.4 ln t plus 1 divided by what is in my bracket, which is 1 plus ln t plus 1. And we are very close to the expression that we need, so I'm going to show you again this expression. They have separated this minus 1, but I have my denominator as it should be. So just I'm missing the 0.4, sorry. I'm missing one 0.4 here. This one here, yeah? When I make t the subject, I'm dividing by this together with this. I'm going to divide by the 0.4. So if I divide by the 0.4, 10 divided by 0.4 is 25, and then 0.4 divided by 0.4 is 1, and then I have 1 plus ln t plus 1. So it's almost there. What I can do is to write the 25 as 26 minus 1, yeah, and minus ln t plus 1. I'm just writing 25 in another way, because this is going to allow me to separate t plus 1. So I have 26 divided by 1 plus ln t plus 1 minus 1 plus ln t plus 1 divided by the same 1 plus ln t plus 1. This whole thing is 1, so I have this minus 1, which is precisely what I needed. So t is going to be 26, which is a very strange way of writing it, but you are going to see why in a minute. Plus minus 1. Yeah, that's the expression that we needed to find, and that's how we find it. So we derivate, we make it equal to 0 to find the maximum, and then we just work with the expression. There are more ways of finding the expression from where we started, but it's just the one that I thought of. Using the iteration formula, which is this one, that's where we found this expression, just to help us to iterate. With t17, find the value of t3 to 3 decimal places. So what we are going to do is just, with the calculator, substitute t1 here to find t2. When we have t2, substitute here and find t3. And that we can do that as many times as they ask, but they just ask up to t3. I would put this expression in the calculator, and every time you find an answer, I will put it in the memory and then substitute the value by the memory one. Yeah, so you don't miss decimals and you don't round until the very end. So if you do that, so t1, so this is for C, t1 is 7. When you substitute t1 in the formula to find t2, you get 7, 4, 4, 3. I'm rounding to I don't know what I'm rounding. I'm not rounding yet. T3 is 7.298. This one is to 3 decimal places. That is what they ask. Yeah. So this is T3. And then the last thing they ask is find by repeated iteration the time taken for the car to reach maximum speed. We can keep iterating, and they are not telling us for how long. So what we are going to do is to try a few more numbers and see where this goes. Because at one point you will start to see that the numbers become very similar to each other, and then you can stop and round to something that makes sense. So again, we just keep the values in the calculator and we just keep iterating and substituting the one before. So if you do that, you have this. T5 is 7.3292, and you see that they become closer to each other. So 7.3345, and this one is already 7.3324. They're becoming close and close to 7.33. So if we round, for example, to 2 decimal places, we can stop here. Yeah. So we can say that the time for the maximum velocity, because remember we are solving, really what we are solving is this time, we are finding this time that makes the derivative 0. Yeah, we are not finding this time, this is 25 seconds, we already found it, we are finding this maximum here, and we are finding that making derivative equal to 0, that gives us this equation that is not easy to solve, and we are iterating to find that value. Yeah, and this is going to be to 3 decimal places, or to 2 decimal places, 7.33 seconds, 2, 2, decimal places. Yeah, and that's how we do this question.